What are temperature scales? Thermodynamics Fundamentals. Have you ever wondered how we measure temperature and why it matters in thermodynamics? Understanding temperature scales is essential for grasping the fundamentals of thermodynamics. Let's break it down together. Temperature scales are systems that help us quantify temperature, which is linked to the average kinetic energy of particles in a substance. In thermodynamics, temperature plays a vital role. It influences heat transfer and helps determine thermal equilibrium between systems. There are several temperature scales, but the most commonly used ones are the Celsius scale, the Fahrenheit scale, the Kelvin scale, and the Rankine scale. The Celsius scale is based on the freezing point of water at 0 degrees and the boiling point at 100 degrees under standard atmospheric pressure. This scale is widely used in daily life and scientific contexts. The Fahrenheit scale is primarily used in the United States. On this scale, water freezes at 32 degrees and boils at 212 degrees. It is less common outside the U.S., but you may encounter it in some recipes and weather reports. The Kelvin scale is the absolute thermodynamic temperature scale used in science and engineering. It begins at absolute zero, which is the theoretical temperature where molecular motion stops. Absolute zero is 0 Kelvin or minus 273.15 degrees Celsius. 1 Kelvin degree is equal to 1 degree Celsius, but the Kelvin scale does not include negative numbers. The Rankine scale is similar to the Kelvin scale but uses the size of the Fahrenheit degree. It is mainly used in certain engineering fields. The Kelvin scale is particularly important in thermodynamics. It is an absolute scale that relates directly to the physical properties of matter and energy. It is defined through principles such as the Carnot cycle and the concept of entropy. Temperature measurement relies on the idea of thermal equilibrium. This means that when two systems are in contact and there is no net heat flow between them, they share the same temperature. This concept is formalized in the zeroth law of thermodynamics, allowing temperature to be a measurable and consistent property. In thermodynamics, temperature is more than just a number. It is a measure connected to energy transfer and changes in entropy. The thermodynamic temperature can be expressed as the ratio of heat transferred to the change in entropy. This reflects its essential role in energy transformations. Temperature scales have practical applications in thermodynamics. They are crucial for designing engines and refrigerators, where efficiency depends on temperature differences measured on absolute scales. They also help in understanding phase changes, chemical reactions, and material properties, all of which are temperature dependent. In scientific research, precise temperature control and measurement are essential. Fields like cryogenics and high-temperature physics relying on accurate temperature scales. By using temperature scales, especially the Kelvin scale, thermodynamics provides a universal framework to describe and predict how energy moves and transforms in physical systems. This makes the principles of thermodynamics accessible and applicable across various fields of science and engineering.